Earth could lose its habitability in many different ways, and this would look like becoming inhospitable to all life, including human life. And these several different ways include changes to temperature, atmosphere, and long-term solar evolution. One major pathway is the runaway greenhouse effect, and this is where the increasing heat would cause the Earth's oceans to evaporate, and then as water vapor rises into the atmosphere, it would enhance the warming even further. And then over time, the ultraviolet radiation would break water molecules apart, and then hydrogen would escape into space, and then this would permanently dry out our planet. And then eventually Earth would become hot and waterless, and it would be and it would have a surface temperature that was too extreme for life. A second way is through the gradual brightening of the sun, and as the sun ages, it fuses hydrogen more intensely, and this raises the amount of energy Earth receives, and it would push it closer to or beyond the habitable zone. A third possibility involves geochemical instability, such as the breakdown of Earth's climate regulation systems, like the Silicic weathering cycle. And if these long-term feedbacks fail, then Earth would just swing between extreme greenhouse or frozen states, and this would look like large-scale volcanic activities or massive, like atmospheric change. And this could lead to the destabilization of global climate and oceans. And then humans may be able to delay or reduce these risks, especially the ones caused by increasing solar radiation. For example, like we had talked about in lecture, a planetary scale sunshade or other forms of solar radiation management could reduce incoming energy and help stabilize Earth's temperature, but we can't stop like the sun's long-term evolution. So there is methods, but sometimes they're only temporary solutions.